All right, we are dealing with 4-4. This is 6th hour. I know, Gracie, you're in 5th hour, but the notes are the same. All right, we are dealing with addition and subtraction. Right, so we need to be able to find the sum or difference of rational expressions. Much like we did with multiplication and division, I'm going to do arithmetic first. So, how do we add fractions? Let's try 1/2 plus 2/3.
We need a common denominator.
Exactly. Good job, Chloe. What's the common denominator with 2 and 3?
6.
Good. So, something over 6 plus something over 6. Notice the structure of what I'm putting together here. I'm giving myself a template to use. I'm not messing with all of this to go there. I'm just saying, I know my common denominator here first. I'm not doing any math or anything yet. I want to give myself a place to put my numerators.
Can I have a ruler?
With that being said, what is the numerator of, what is the numerator of the first fraction? 3. Good. What's the numerator for the second fraction? A 4. Good. And when we add those together, we get 7 over 6, or 7/6. Good job.
I'm so glad we left, like, you know what.
What happens when we subtract? Let's try 3/8 minus 5/12.
We still need a common denominator.
Yes, we do. You got that right. So something over 24 minus something over 24.
Question, how do you find the common denominator?
Great question. When it comes to arithmetic, we want to find the least common multiple. So the first one was 8. So 8, then 16, 24, 32, etc. 12, 24, 36, 48, etc. So what is the smallest number that these two have in common? 24. Hey, Dally, you need to be patient when other people are learning. I understand that you knew, but you talking while I'm talking is not helpful for people when they're trying to listen. No, you're good. I have to teach you these things. You didn't know that, but now you know that. We're going to respect it. No, she doesn't. She doesn't. She's good. All right. So, what is the numerator for that first one going to be? 9. Good. And the numerator for the second one is? 10. Good. Yes. Hey, listen. Pause. Stop. It's not your turn. My turn. I'm going to dissect this in a moment. I will help you figure this part out in just a moment. How do we find those numerators? How is everybody able to get these so quickly? I'll share that with you, but I want to do it in a very structured and organized way. Okay? I'm going to get you there. I promise. That I will answer. All right, so 9/24 minus 10/24 is a total of? Yeah, -1/24. Good. All right. Now that we've done arithmetic, we do not have to do this problem. Sweet. Don't worry about him. Roll it over, Smokey. No, you're fine, dude. You're good. We're learning. So, how do we add rational expressions if we have a common denominator?
Straight across.
Straight. Yeah, good. So, what is this going to end up being?
5x.
Are we multiplying or adding?
Adding.
So, how would we add?
Oh, 6?
What?
Wait. Wasn't it x1?
Yeah, I have 1x and a 5. X plus 5, yeah. They're not like terms.
Wouldn't the bottom one be 8x squared?
Is it?
X plus 4!
I've never
Yeah,
done
so
that.
let's think about it. If I had 1/2 plus 5 halves, I would have a total of 6 halves. Not 6 over 2 squared or 6 over 4 or anything like that. Right? We're not multiplying the denominators. If I have a common denominator, then the numerators get combined.
What is on top of that?
Okay, yeah, I never did the x plus 4 with that.
You're right. You're okay. That's why we're trying it out.
Don't you even say it, Dally.
We're trying it out. All right, sweet. Let's try the next one. As a note, yes, we have. I'm listening.
Oh, on the first one, why didn't you put x plus 4 straight?
Because
Okay, here's the reason why I don't. Because here in this situation, whenever I have common denominators, right, 1/2 plus 5 halves is a total of 6 halves. Once my denominators are the same, I just add the numerators. It's over 2. It's not 1/2 plus 5 halves equals 6 over 2 squared. Now, did you hear it? All right, good. Sorry, Gracie, for repeating myself, Gracie Fanning. Yes.
I have a question.
Answers.
So, x plus 5 over x plus 4, you can just cross the x's out.
Oh, I love that question. Now, x plus 5 over x plus 4. Is that the same? Could I cancel my x's? Is it always going to be 5/4?
No.
How do you know?
Because you're not always going to.
How do you know? Give me a number.
7.
7. So 7 plus 5 over 7 plus 4 would be 12/11ths. Is that the same as 5/4?
No.
So can I cancel the x's?
No.
No. That is a good question. That is a really, really, really good question. Thank you. Thank you for asking it. Good job. All right, to finish this note here, sorry, Gracie, I know you were trying to write it. When we have common denominators, when we have common denominators, simply CLT them numerators.
Combine mindset.
All right. Now, do I have common denominators here with this part B?
No.
It doesn't look like it.
But it is.
Yeah. So if I look at this first one and I factor out an x, I would be left with x plus 3. That's one way to look at it. If I didn't see it that way, what if I distribute my x here? X times x is x squared, and x times 3 is a positive 3x. Are these the same denominators?
Yes.
Yeah, so all we have to do is simply CLT them numerators. I don't know why that all of a sudden sounded like I'm countering. All right, so when we combine like terms with the numerators, what are we left with? Ooh, close. I agree to the 5x.
Oh.
Minus 7. Yeah, good job. Nice. Way to go. Alliteration Lily. Okay, all right. Twice, yes.
Yeah.
Yeah.
Her middle name isn't part of the alliteration, though.
What's her middle name?
It's probably like Marie.
M-A-E.
Oh, that's
It could
funny.
be Lily Lou Lewis.
My name was gonna be.
Which one?
Thank God.
Lily Lewis likes licking
Lilies.
lollipops.
Lily Lewis likes lilies.
Lily Lewis likes lilies. Leftover.
Last.
Lily Lewis likes leaning lilies.
Lily Lewis likes leaving little.
Lunch pails.
Pails?
Yeah, lunch pail. It's got to be one word, right? Or is it
What's
two
a
words?
lunch pail?
Yeah, oh, okay. You know what?
Little Lunchables.
Back in my day.
What's an
Come
icebox?
on. I don't know what a lunch pail
Guys, you're getting
is.
off your.
It's just a lunchbox.
Oh, bruh.
All right, so here we go. Try them
All
out.
the people turn.
Find the sum. You know what? You guys could do these on your own. They're too easy. All right. What do we do if we do not have like denominators?
You gotta make them like.
You gotta make them like denominators. Exactly right. So let's go back to the first page.
I'm trying.
Let's go back here. We did, but we now have to deal with what happens whenever we do not have like terms. So, or like denominators. No common denominator. I'm going to redo this problem. Instead of putting it over 6, what if I had said this is over 2 times 3? Leave it in factored form. Now, listen to the wording of what I'm about to say. This is the most important part to this. I've just taken whatever denominators I was given and I put them together to make my common denominator, right? I multiplied them as my factors of the common denominator. Now, I start with the original numerator and I multiply it by the factor that we gained. So, what factor did we gain from 1/2 to something over 2 times 3? What factor did we gain?
Times 3.
We gained the 3, yes. Now, for my second fraction, the original numerator is a 2. Now, what factor did we gain in the denominator?
The 3.
We gained a 2.
I meant the 2. I was looking at the wrong spot.
Now, that's where the 3 came from, and that's where the 4 came from.
Oh, okay, that makes sense.
I'm going to do that same problem.
Learned it that way.
I'm going to, well, not that part. I'm going to do the same problem here. 8 is really 2 times 2 times 2. And 12 is 2 times 2 times 3. So we had 3 over 2 times 2 times 2 minus 5 over 2 times 2 times 3. Now, our common denominator here. Pay close attention to this piece. Our common denominator. What do they share?
The 2 times 2.
They share 2 2's. And I'm going to multiply it with my leftovers. So, I'm going to see if I could do this with... What do they share? They share the 2 times 2's. So my common denominator is something minus something here. My common denominator is going to be 2 times 2. And then I need to multiply that with the leftovers. What extras do we have?
2 and 3.
A 2 and a 3. So times 2 times 3. So 2 times 2 times 2 times 3. So these 2's came from where they shared.
They're friends.
And this 2 came from him. And this 3 came from him. Oh, I should do that with here too. Now, the original numerator times the factors that we gained. So that 3 goes here. And now what factor did we gain? From 2 times 2 times 2 to 2 times 2 times 2 times 3, what factor did we gain?
A 3.
We gained a 3. The second fraction, the original numerator is a 5. What factor did we gain? We gained a 2. So now, to answer your question, Chloe, do you now see where the 9 came from?
I do.
Do you see where that 10 came from?
I do.
Exactly. What factor did we gain when we got our common denominator? Now, I'm not going to talk like that with, fourth graders that are learning fractions. That would be a nightmare. I'm not going to talk about factors, especially because they're not dealing with polynomials like we are. But I want you to be able to see a 2 here is the same thing as like x minus 3. A factor here would be the same thing as a factor in parentheses. So, let's get to this problem here. So we're on example 3. Add rational expressions with unlike denominators.
Right.
We want to start with factoring. So sum, that's addition. We have x plus 3 over plus 2 over. Now, I want to start with my factors. What are the factors of x squared minus 1?
1. Negative 1.
Go ahead, Jaden. Loud and clear, please.
X plus 1, x minus 1.
Very good. Yes. X plus 1 times x minus 1. Really good job. The factors of this trinomial, x squared minus 3x plus 2, the only thing that multiplies together to get x squared is x and x. The only thing that multiplies for 2 is 2 and 1. Same sign or different?
Same.
They're the same, and they're both going to be minus. All right. Now, I'm going to set up my 2 fractions for common denominators. So I have something plus something. What factors do they share? They share an x minus 1. And I need all the other factors that you see. An x plus 1 and an x minus 2. So our common denominator, x minus 1 times x plus 1 times x minus 2. Now I'm going to leave it all in factored form because that's way too much work. I'm not going to multiply all that out. I'm just going to leave it in factored form. Now, if you were listening whenever we were dealing with arithmetic, we write the original numerator, and we want to multiply that by what? The factor that we gained. Exactly right. So here, the original numerator for the first fraction is x plus 3. Good.
I meant 3. Oh my gosh.
It's okay. Austin, it's 6th hour. You're doing great. What factor did we gain?
X minus 2.
An x minus 2. Good. For the second fraction, what is the original numerator?
2.
2. What factor did we gain?
X plus 1.
We gained an x plus 1. Good job.
Good job, Lillian.
Oh.
Thank you.
I'm glad he came back and gave you a raise.
I would not do that.
I would have forced
It was pretty crispy, too.
Let's not get Stevens to do that.
Now,
No,
here we are.
Please get Stevens to do that.
Can you dab?
I've never dabbed and I will never dab.
Can you
I'm
dab the
dabless.
camera?
I'm dabless. All right, so now I want to take my 2 fractions. Now this is the part that's going to be new to us. I'm going to take my 2 fractions and combine it into 1 fraction. So I only need one common denominator, x minus 1 times x plus 1 times x minus 2. I mean, we could write it twice if you want to, but we have a whole other step. You're welcome. Thank you, Mr. Steven. All right, we got to FOIL this guy out. X plus 3 times x minus 2. We have to FOIL this out, and we have to multiply these out so that we can combine like terms. Right? That's the whole idea. When you have common denominators, you want to combine like terms. I don't have like terms yet because I have not multiplied them. So we have x squared minus 2x plus 3x minus 6. That's the numerator for the first fraction. They already have like terms, but we're going to get to it. Now we're going to add. I'm going to add plus. Good. Distribute that 2 through. We get 2x plus 2. And now, I just combine like terms in my numerator, and I should be good to go. So, the denominator, x minus 1 times x plus 1 times x minus 2. Nothing's changed there. When we combine like terms in the numerator, what's the first one going to be? Got that right. Yeah, negative 2x plus 3x is 1x. 1x plus 2x is a positive 3x. Good? Minus 4. Great job.
Good job, Lillian.
Now, check this out. Can I factor that numerator?
Yes.
Sure can. What are the factors of the numerator going to get us?
4 and 1.
Same sign or different? Bigger one will be? So plus 4 minus 1. Will anything cancel? Yeah, the x minus 1s are going to cancel. Boop, boop. So the final answer, we're left with x plus 4 over x plus 1 times x minus 2.
Can you bring that up?
Yeah, I can. Yep, absolutely. So note, after we CLT the top, comma, just do a simple check to see if anything can cancel. Okay? This is the one unit in your entire high school career where I'm going to encourage you to participate in cancel culture. Okay, that's not a funny dad joke. I tried.
Why is Addison?
Dally Harper, canceled.
Yay!
You're welcome.
Said yay.
Are we still going? Anybody still writing?
Me.
Okay.
We got Gracie.
I'm very proud of myself.
Yeah, you're dude, when you're on it, you're on it. Good for you.
Strawberry and
We need to know how to do.
Right. Adding and subtracting is tough. Multiply and divide is so easy. So if you can latch on to the easy parts, the harder parts become much more simple because it takes fractions and turns it into, oh, I just need to know this part. And then once you get used to common denominators, you're like, okay, so it's all just relatively simple.
I'm really bad at math.
Okay. All right, here we go. Find the sum.
Where do we go?
Oh my. You know what? I'm gonna save that. I'm gonna let you guys do that one on your own.
Oh, girl.
I know, me too. All right, let's hop down to example 4. Let's subtract these rational expressions.
your legs.
I don't like you.
Get out of my life.
Here we go. You don't know me.
No, you.
Here we go. We have x plus 1 over All right, what are the factors got to be here? X squared minus 6x minus 16. What factors do we get? 8 and 2?
4 and 3. 4 and 4. Oh my gosh.
Yeah, right. 4 and 4, but will 4 and 4 subtract to negative 6? Or 6? No, but 8 and 2 will. Yeah. All right, so we have an x and an 8, x and a 2. Same sign or different?
Same. Different.
The bigger one will be, all right, so x minus 8, x plus 2. All right, cool, double cool. Minus, all right, so this time we have subtraction. Minus, we have, what are we going to get for our factors here?
4 and 2.
4 and 2, same sign, both positive. All right, okie dokie smoky. Now we can figure out our common denominator. So we have something minus something. Jaden, can you tell us the common denominator?
Oh my god.
X minus 8, good. X plus 4, good. X plus 2, good. Yeah, that's it, right? They share the x plus 2, and then the extras are x minus 8 and x plus 4. Oh, all right, you guys make good choices. I will see you tomorrow.